All right. I think we're all set when you are. Got the
All right.
reports.
Yeah, very good. So let me share my screen. All right. Can you guys see my screen here?
Yep.
Okay. Very good. All right. Thanks, guys. Appreciate you guys asking me to come and chat about NodeRed. Um, I'm assuming most of you have probably heard about NodeRed, maybe in uh, a prior presentation, maybe. So this is going to be pretty much a deep dive into NodeRed. Hopefully, after you get done with this presentation, you'll have a good idea on what NodeRed does and be able to configure it and get into the nuts and bolts of it. I get pretty deep into the how NodeRed works in this presentation. So that's what this presentation is going to be. If you have any questions about NodeRed or how to configure things, I'm going to show you a bunch of utilities and things that you can do to help yourself get up to speed. And also, I'm always available and around. I answer email. I've got a YouTube channel with all this information out of it. Check that quite a bit. So I'm available to help you guys through your NodeRed journey if you need me to kind of give you a pep talk and give you ideas on what road to go down. But so this presentation is basically building custom dashboards and control web pages for your Shack. If you've got, and it's really not just for your Shack. You can pretty much do anything with NodeRed, as I've figured out throughout the years on working with NodeRed. So let's just go over the high level stuff, and then we'll get into the actual cool stuff, which I think is pretty neat. So it's developed by IBM in 2013. 3.0.2 is the latest version. It's built on Node.js, which is basically JavaScript, and NodeRed was created back in 2013 to basically connect the Internet of Things devices together. We have just basically migrated it to ham radio stuff because you can get inputs and outputs out of ham radio things. And we have basically ported it over. I talked to Nick O'Leary, who is the developer of NodeRed, and he was flabbergasted that we were using it for ham radio stuff. He couldn't believe it. It basically runs on anything: Windows, a Mac, Linux, Raspberry Pi. I suggest using a Raspberry Pi. It runs 24/7. That's how I run it, and it's probably the best way to run it in something that runs 24/7. You'll see on a Windows client, you basically have to boot the Windows machine up, and then you have to start it by a DOS command, and then if you that DOS window shuts down, so does NodeRed. So running it as a server on a Raspberry Pi or a Debian based Linux system is the best. And also, it hides all the boilerplate code. So back in the day, whenever you actually had to write TCP structure and command structure, if you don't know how to program, NodeRed is for you. It is. I don't know how to program. I didn't go to school to be a programmer. I took some programming classes like Fortran and Pascal, but that was about it. And if I can do some of this stuff that you're seeing, anybody else can do it. It's very quick and dirty, and it gets the job done. Down here are a couple of are on the left-hand side. Sorry, is what we call a flow. So those are building blocks and connecting those building blocks together to perform a task. And then after you perform that task, usually you display things out on a dashboard. And then this is what a dashboard looks like on the right-hand side. Keep in mind, all of this is web-based. You run the server on a device that runs 24/7, like a Raspberry Pi, and then you connect your computer or your laptop via a web page, Chrome, Safari, Firefox, whatever, to the Raspberry Pi or the server, and all of the programming, all of the dashboard, it's all web-based. So I'm not going to dwell on this this slide. Basically, it is one of the easiest programming languages to program in. You don't need to be a programmer to do cool stuff in NodeRed. One thing that I will stress over and over is debug nodes are your friend. Everyone hates to debug, but they are your best friend. And I'm going to show you some tips and tricks on using the debug node to make sure that you're getting the right stuff out of your flows. So what can NodeRed control? Basically anything in your ham shack, and basically anything in the world that has an input or output. But in the shack, we can use anything that has an Ethernet, a serial, or a USB device, or a input or output. Most radios with hamlib, or there's another that I think it's called Omnibus or OmniRig. Sorry, OmniRig. You can get cat control out of your radio, amplifiers, tuners, rotors, antenna switches. Basically, anything that you can get a serial or a USB or an Ethernet communication in and out of, you can control via NodeRed. So this was a slide that I put together based on somebody coming up to me after a presentation and saying, I don't get it. Why do I want to run NodeRed? And it's all about automation. So as I walk around the circles here, be thinking about your shack and the things that you do in your shack that you could possibly automate. So one, whenever I contest at my contest station, we have crap all over the place. Like, the antenna, the amplifiers are behind me. The rotors are up on a shelf. The bandpass filters are over on my right-hand side. It's all over the place. And I have to make sure that all the things are in the right settings whenever I'm running or searching and pouncing on a band. Well, we have taken all of that guesswork on looking over your shoulder and put it in one location, which is your monitor. And I can see the status of all of my devices in my shack, in my monitor in front of me. So that's we can monitor everything in one location. We're also getting real-time feedback. I'm not really sure how many times I've looked back at my amp and I'm on the wrong band, or the amp is going crazy and I didn't know it for 15 minutes because I've been running, right? Again, I'm getting real-time feedback on all my devices. Command and control. We've got a remote station that I remote into. I live here in St. Louis, and my remote station is about 2 hours south of me. And I'm able to turn different things on and off remotely through a VPN, and that's how I contest remotely. Custom alarms. So again, high SWR. That's the time that the amp was freaking out, I had no idea, and it would have been nice to have some type of red alarm to go off to say, hey, something's wrong with the amp, or your SWR is out of whack. You need to go take care of it. And then also eliminate errors. I don't know about you guys, but whenever I'm contesting at 3 o'clock in the morning and I forget to do something because I'm tired, one of the things that NodeRed can help you do is I can switch from 20 meters CW to 40 meters single sideband with one click of a button, and it switches the amp, it switches the band, it switches the mode, it switches the filters, it switches everything automatically, so I don't have to do one thing. I just had to hit the button to go to the right band and mode, and I'm ready to contest, or I'm ready to DX, or whatever you want to do. So how does this all connect, right? You've got your Raspberry Pi here at the bottom, and it's connected to, a bus through Ethernet. But we've got all of these different things that need to connect, right? So let's kind of work through them here. Power. We've got an Astron power supply, and here is a Digital Loggers Pro. And what we do is that is controlled by NodeRed through an Ethernet cable, and we keep the power on, the button on the power switch here, and we plug that into one of the relays. This has got 8 AC relays, on and off relays, then it's got 2 that are always on. And then if we need power to something, we switch the relays here and we provide power to the devices that we need. A radio, an Elecraft radio, basically all that stuff is just serial data, right? It's connects directly into the USB port on the Raspberry Pi, and we're able to get data out of this this K3 or this K3S. Flexes are the easiest to get out of information out of. They have an Ethernet port on it, and we've actually built nodes for Flex radio. Here's an amp that might plug into USB that's got some information, a tuner, a Palstar tuner. These antenna disconnects, they are really cool. Basically, they connect, they latch whenever you provide power to them, and they unlatch when you disconnect power. So we've got a bunch of these at the contest station where, it's a gap and it's got a discharge tube in it, but it doesn't, you need to do your proper bonding and grounding for lightning protection. But this gives another layer of protection of when we're not contesting, when there's storms in the area, we disconnect power to these Paradan antenna disconnects, and provides just, a little bit more protection. Antenna switches, we use AA0Z boxes connected to 6-packs, 2x6 array solution 6-packs for antenna switching. We've got some bandpass filters down here that are just switched via serial. If you got anything that has RS-232 that you want to convert to Ethernet, these USR N540 devices are really cheap, and you can get them off Amazon, and they plug into Ethernet and are controllable by NodeRed. If you need some relays, these KM-tronics on eBay are really good. They're $80. They're connected via Ethernet. They run on 12 volts. This thing runs on 12 volts, and it's got 8 switchable, normally open, normally closed relays. And then rotators, we've also used some EA4TX boxes for rotator control that plug into the Raspberry Pi, and we're able to control our towers through NodeRed. So this is just an example of how you can connect radio. Some people are just like, well, that's great if we can connect serial devices and amps and whatnot, but how do I connect my radio? Flex has got it going on. They've Stephen Hauser, N1SH, has created Flex radio nodes for NodeRed, and you drag and drop them, and you basically configure the nodes on where your Flex radio is, and automatically connects. Brings even things in like the fan speed on your Flex radio. Serial, again, a K3 or K3S, and the K4 HD that Elecraft has come out with. All of those plug directly into the NodeRed system, and you're able to read all the cat control via serial. And then if you don't have anything that has an input or output that is easy, you can always do HamLib or OmniRig, and basically it provides an API that you can connect through that third-party application and get information from your radio, send to and from. So let's go over some dashboard examples. Some of these I think that I need to replace because they're not very clear, but as in, eyesight clear, they're just a little bit fuzzy. But here is a dashboard. You can see an HF amp. I'm on the left-hand side if you can't see my cursor here. This has got a stepper IR that is, you can track here. Over here on the right-hand side is a bunch of gauges that show, it looks like actually this is, maybe not. I was going to say satellites, but I don't see any. I see the word satellite, but anyway, I asked some people to give me some examples of what their dashboard looks like, and they've sent these in. So these are buttons down here. Obviously, these are gauges. And then you've got some switches here that are actually pings. They're ping statuses to tell you what's up and what's down. Over here on the left-hand side, I call that the Fruity Pebbles. That's Alan up in Michigan. He is a NodeRed master and is pretty much our Elmers on the group's IO. That's his dashboard. Here's Mike Walker from Flex Radio. Here's his dashboard. Alan actually down here in the lower left-hand corner created a SWR sweep that basically sweeps the bands and tells you what the SWR is for different antennas. Here is Dave DeCoons, WO2X. You can see he's got some Flex Radio stuff, Power Genius, Tuner Genius. Here is his rotator. So this is a clickable map. You basically just click on the earth where you want your rotator to or antenna to point to, and it rotates. Here's some buttons, some preset buttons. Again, some switches that turn things on and off. Some gauges here, and then obviously he's got his Flex Radio. Here's a 2-tower system. This is W7GES. You can see some switches over here to turn things on and off. He's got his azimuth bearing map here. Again, clickable with some presets. One thing that you can do is you can style these with CSS, and somebody has styled their NodeRed dashboard here. Here is a version of mine at the contest station. Actually, I'm going to show you at the end. We'll take a look at what this looks like today. But this was an early version of just command and control, and then we've got some other things that. Here's the towers. We got 3 towers at the contest station, and then a 6-pack array, and then we've got some WA4 MCM switches that are at the base of the towers, and they switch the individual antennas that are, there's switches at the base of the tower, and they switch the switches to the tower. Here's some other things that you can do in NodeRed. You can pull images in and display things on a map. So we've got some band activity in the upper left-hand corner. We've got propagation map going on. We've got some solar information. Here is a clickable map that shows all the de-expeditions that are going on and what their call signs and their date, their times that they're going to be on the air. We've got some general solar data that you're probably familiar with, a geochron. And then on this down here, I'm mapping all of the POTA sites that are actually on spotted right now. Here is a cluster aggregator that I created. So it takes all of the active cluster spots and shoots them into one location so I can get all of the information. I didn't understand for the longest time that cluster sites are supposed to replicate, but some of them don't, and you can get different information on different clusters. So basically, I just wrote a NodeRed script that took all of the information, and it looked for dupes, and if it had dupes, it just threw them out, and therefore, I have a cluster node, a NodeRed cluster node running at my house, and I connect to that, and I get more spots than the usual person because I'm aggregating all the spots together. Here is let me take a drink. Here is a NodeRed script that I wrote, or a flow that I wrote, that basically maps all of the locations from the reverse beacon network. So you call CQ, and it basically puts on a map where you're being heard from the reverse beacon network. It's kind of nice in a contest to figure out kind of where propagation is going and where you're being heard at. I also created the NodeRed contest dashboard. It's basically 6 or 7 dashboards that take all of the information from N1MM through UDP packets and puts it in a database and crunches numbers and displays it for other people that might be, at your shack or in a multi-op, that they can see that information instead of hovering over people whenever you're contesting. Here in the upper right-hand corner is basically I'm making a contest within a contest. So whenever we do a multi-op, we might have, 10 people show up at the multi-op, And so this basically pairs people against one another within the multi-op and makes it a contest within a contest. So let's talk about what is a node. So these are nodes. So you got different types of nodes that you can pick from to put from your palette into your workspace. Most common is a timestamp node. You can see that these got these little nubs on the debug and the timestamp. Those are basically start and stop. But you can take a timestamp and basically say, all right, I want you to inject or start this flow every 3 seconds, and it will automatically go every 3 seconds. The other node that will become your friend real quick is the debug node. You have to use that early and often. And then basically you can turn the debug on and off by this little nub here. Function node, so if you want to write some raw JavaScript, you can do that in a function node. A switch node is basically a big if then else. A change node, if you want to change message payload, which is the default payload that you can pass between nodes, you can change that. A comment. And then everything in teal in your palette, and I'll show you this later, is a dashboard. And it takes usually an input, which is these junctions. Everything pretty much has a junction, but typically dashboard nodes have one junction, an input, and it displays things on the dashboard. So here I'm showing a dashboard button, a drop down, a text box, and a gauge. So each node has a configuration page. So if you double click, once you drag the node over to your workspace and you want to configure it to somewhere in your flow, you can double click on those nodes and they will give you a configuration page. And I just pulled 4 here. So an inject node, which basically is a timestamp node, this is the default configuration for that node. And you can see it's got different parameters. One of the things is we talked about message payload, which is the default payload that you're passing between nodes. You can pass other things, but that's the default. So in this case, we're injecting a timestamp, which is basically a Unix timestamp, and it gets the flow going. You can inject a string, a number, whatever you want here. And then down in the bottom here, you tell it what you want the inject node to do. You want it to repeat. If you do, you can say repeat it every 1 second, every 2 seconds, every hour, whatever the case may be. A debug node. So the output from the debug node is typically message payload, but I typically say or give people the advice to, there's a drop down that says I want to see everything. I want to see all of the node ID and the timestamp and all this other stuff, and you can get that out of the debug. A switch is basically just a big if then else statement. So in this case, I'm checking message.payload.mode, and if it equals CW or FT8 or FT4 or single sideband or PSK31, it goes out each one of these junctions, 1, 2, 3, 4, 5, or otherwise, if it's not anything else, go out number 6. So this is what this looks like on the workspace. So if it was CW, if message payload.mode equaled CW, and that's a string there, if the string equaled CW, the flow would continue. The message would be passed out this junction number 1. If it was FT8, it'd be passed out this junction number 2. And a change node. Let's say you want to set something in your flow. So I want to set message.payload.icon color to the value of, and then that hexadecimal color. I'm not really sure what it's at. But then also, let's say we want to set message payload layer to the value of CW. You're able to do that with the change node. Now you can do all this stuff with function nodes and write your function nodes, your cases, your if then else statements. You can do all that stuff through a function node too. So here's some dashboard. Dashboards have configuration pages too. They have an assignment group. They've got a size because you have to size them on the dashboard. They've got a label. They've got the value that you want to pass into the dashboard node. They've got a layout of how you want the dashboard to look. In this case, it's a text box. So do you want the label to be on the left-hand side and the value to be on the right-hand side? Do you want it to have to be centered? Do you want to have it up and down? Class, if you have an optional CSS parameter that you want to give it, and then a name. Basically, this shows up in the dashboard sidecar to help identify where this thing is at. Here's a button. Button's got a group, a size, an icon. You can basically use Font Awesome or Material Fonts from Google to make your custom icons here. A label, a tooltip, so if people hover over it, it's got a tooltip, a color, a background. When click, send, and you can say what to send. Yeah, name. Gauges here, so you can gauges have got a group, a size, a type, so you can have different types of gauges, a label, the value format of what is being passed in, and then a range. So this one's 1 or 0 to 100, and the color gradient as the gauge goes, you know, from 1 to 100. So you can put values in there, and then a class, then a name. All right, so let's go over a sample flow here, and hopefully some of this makes sense. So here we talked about an inject node, right? So we have pulled this over, and we're going to inject every second. So we've got that configuration page. We say, all right, start this flow every second. And then every second, let's say there's an Elecraft, and we've got this connected to our NodeRed Raspberry Pi. So we might inject a string, and let's say we inject an M for mode and an F for or B for band, okay? So whenever we inject that value into the Elecraft K3, it's going to return a value, okay? So we connect to the Elecraft radio through the serial device. We send it a B, we send it an M, and then we're coming back into the flow, we get the band and the mode, okay? So now we need to break out that band and mode based on, like, is it a value or is it a word? Is it CW or is it a number? Maybe the number is 40, right, for 40 meters. So we do that in the switch node, and we break that out. So if it's a string that we identify as CW, let's say, then that's going to break out that piece of information. It's going to bring it up here to this second switch node. And then we're going to determine, was it single sideband? Was it CW? Was it digital? What was that value? And then it's going to break out that even further, and it's going to send this to a change node, and we're going to set the mode to single sideband, or we're going to set the mode to CW. And basically that is, we're just setting just a text box or a string. And then we're going to display that mode here in a dashboard node, okay? Same thing with band. Here we might have 20, 40, 80, 160. So that will determine which junction this comes out of, and then maybe we change that number value to a string, and we set the band to 160 meters or set the band to 80, and then we display that in a text box on the dashboard. Does that make sense? Talked about this Digital Loggers Pro. If you want to automate your shack, this is probably one thing that you want to get here. So this is the flow here, and this is what a default dashboard looks like. You can see that on switch 1, we've got the amp rack. Switch 2, station A. Switch 3, station B. Amp rack pi is station 4. Amp A is 5, and amp B is 6. So you can buy these things for about $180. And they have they've got automatic reboot of, actually, they just turn the power off, but you can program these to say, hey, go out and ping Google, and if you haven't gotten a ping from Google in 5 minutes, reboot this port, which might be your WAN router. And what's the first thing that customer service or the tech support people say whenever you've got an internet outage? Have you rebooted your router? This automatically takes care of it. Here's this KMtronics web relay that I talked about that's got Ethernet in, and it's got 12 volts in, and it's got 8 normally open, normally closed relays here. This is the flow. And in this flow, I have a bunch of flows or ports disabled. You can see that they're disabled here by their grayed out, but I'm using relay number 1, which is here on the top, or relay number 8, which is on the bottom here. And this is how I turn my flex on and off through these relays. You can also monitor your Raspberry Pi. You've got exec commands that you can send to the Pi, and you can get different information out of your Pi: CPU temperature, memory, disk space. You can chart stuff. You can shut the device down. You can reboot it, do a whole bunch of things. All right, so let's get installing here and programming. All right, so one script on a Raspberry Pi, this bash script, it's all you need. It installs everything for you on a Raspberry Pi. It's really simple. Again, you can install this on Windows. Basically, you go through the parameters of on this getting started in Windows URL, but you have to keep the DOS window open or NodeRed will shut down. So there's 2 main screens when you first get your server up and running. There is the workspace, and then there's the dashboard. The workspace is at, let's say you're on your Raspberry Pi. It's at localhost :port 1880. Or if you're, got your Pi in a corner and you're connecting through your laptop or a PC, it's the IP of your Raspberry Pi :1880. So that's this workspace here. Your dashboard is located at the same address, but /UI. This is where that dashboard lies here, /UI. A lot of people don't realize that, and they're like, "Where's my dashboard? I don't know how to get to my dashboard." It's where it's at. I know this is blurry. I need to replace this screen or a picture. I didn't do that before I came here or presented. Sorry about that. But this is basically the workspace with a flow in it. That's all I wanted to depict there. So let's take a look at some of the different things in the workspace. So over here on the left-hand side is your palette. This is where all your nodes reside. You've got tabs up here, just like you would have in Excel, right? You can put different flows on different tabs. You've got a sidebar that's got information. Whenever you drag a node over, you can get a help on what that node might need parameter-wise, input or output, and it gives some more information. Here is the sidebar menus, and we're going to get into the sidebar menus, and then your deploy button, which basically is your compile button. After you've gotten some flows in here and it's got some things connected and maybe some debugs connected to them, you want to deploy. You want to test it out. So I've kind of already gone through this, but I want to reiterate this. Function nodes, that's basically all of the Fruity Pebbles nodes over here that have the different colors. They do things like start a flow, connect a device to receive or push information, manipulate data, move data forward through the flow, debug. Your dashboard nodes are the ones here in teal. They're the ones that display information on the dashboard or make the dashboard up so you can interact with it. So let's focus up here, which this square here is the upper right-hand corner of your workspace. So there's a bunch of different icons here that do different things, okay? I got kind of something out of order here, but and then also up here in the corner, I talked about the deploy button. It's got that is your program compile. And then you've got this hamburger menu, and it's got a drop down. This is got a bunch of stuff in it. It's got projects. If you upload stuff to GitHub, this is where you do all that stuff. Import. So I'm assuming you're probably going to import a flow, and it's all JSON code. Whenever you import flows from other people, click on the import, and basically you can select the JSON file, or you can copy the JSON information into this screen, and then you hit the import button, and it imports that information. This managed palette. This managed palette is where you install all the internet nodes that you can find on the internet. Like if you wanted to connect this to a Flex radio, you'd have to go out there and you could search on Flex radio, and then those nodes would pop up here, and you can install them from the repository on the internet. So let's take a look at these buttons up here. They all have a different meaning. Project info is this first one. If you enable projects within the settings file, you've got a help that shows you all of the node information about inputs and outputs. The Git repository is where you push things to Git and GitHub. Debug, that's where all your debug messages show up whenever you enable the debug nodes or connect the debug nodes to your flows. Your dashboard layout, this is where you configure your dashboard to make it look pretty. Configuration nodes, I really don't mess around there too much. It's global parameters that make the program work. And then also you got global variables, local variables, flow variables, and global variables. That's where all that information resides in the variables tab. More debugging. So here I'm just showing you can attach a debug to basically anything, and then you turn them on by these little nubs, right? So these two are on, this one is off. And then whenever you hit your debug node, your debug toolbar, that screen is going to pop up in the sidebar, and that's going to show you all of the information that is coming out of that node and maybe traversing on. So in this case, looks like I've got an object here, and the payload is a string US-AK, and it's got all this other information that is connected to it, but this is what's coming out of this one of these nodes. All right, let's talk about dashboards. So this is the tab. It's got the bar graph. And the only thing that you need to grab out of the dashboards is you've got top level tabs, and you've got groups that go into tabs, and then you put dashboard nodes into groups, okay? So that's the hierarchy. Tabs, dashboard nodes go into groups, groups go into tabs, okay? So here's tabs. If you click on the dashboard and click on the hamburger menu in the upper left-hand corner, you're going to see these are the tabs that I have configured for this instance here. E-layer command and control, antenna switch and rotator, W0 ECC chat control. So I've got all these tabs. If I come here to the dashboard and I click on layout, you're going to see all these tabs. E-layer command and control. Here's E-layer command and control. Here's some other tabs down here. Antenna switch, rotator, W0 ECC chat control. All of that lines up with these tabs in this dropdown. Here, underneath E-layer command and control, these are groups. If I was to click on these down arrows, these arrows to make them down arrows, you would see dashboard nodes put into those groups to make up that dashboard. But we've got an easier way to configure dashboards. We've got this GUI, and basically anything in here is drag and drop and resizable. So what you do is, and it's only by tabs. You can only see whole tabs. You can't. It shows you the groups, but you click on the layout button here on the tabs, and it will slide over and show you all of the groups and all of the dashboard nodes that are associated in those groups in that tab. Okay. And then you can drag and drop however you want your dashboard nodes to line up, and how big, what the width is of your dashboard group. So this has got a width of 6. This has got a width of 3. Most their default is 6, but you can make them as big or as small as you want. Another key pro tip is, if the GUI doesn't allow you to move blocks for some odd reason, it's got a bug in it, restart the NodeRed service. I've learned that the hard way. So here is a dashboard group, and then here is the GUI. So if I come back here, see that GUI here? Here's the GUI that lines up with that dashboard group. So we're just going to kind of go over this. So Raspberry Pi status and control, that's what the group name is. The CPU temperature, you can see that's a gauge, and it has a unit of 3 by 3. So that's what that looks like. Memory used, that lines up here. These two other gauges. CPU temperature, that's a chart. So this is what that chart looks like. And then the reboot button and the shutdown button. Same thing with our weather here. So here's a text box. Weather is the label and clouds is the value. But inside, remember, inside that dashboard node, you could configure if this was on top of one another, if it was side by side, if it was centered. So this is what that parameter looks like whenever it's one is on the left-hand side and one is on the right-hand side. Same thing with weather details. Then we've got a gauge that shows the wind direction, another gauge that shows the speed. We've got the outside temp here. We've got a chart that plots the temperature. And then here we've got an LED that shows if red, if there's like a thunderstorm, and then a switch. This is a lightning control that we've got going on here. So that's basically how these dashboard groups and the nodes configure into the groups. I wanted to throw this in here. You can do SVG elements, which basically are just clickable maps that can show movement on a NodeRed flow. I wish that I could play this, but I can't. But this shows like an actual, kind of looks like a record player, but actually shows the movement of the graphic here. It's kind of cool. Then here's our rotator with our azimuth. Those are, you can download these from the internet and import them into your flow, and it will show within your dashboard. Another gotcha that needs to be said is, whenever NodeRed is installed, by default, I don't know why, but they don't install any dashboard nodes. So your first thing that you want to do is come down here to your hamburger menu and come down here to Manage Palette and click on or search for, or I'm sorry, click on the Install tab, and then click on Enter in Dashboard here into the search field. And you want to install this set of nodes called Node-Red-Dashboard, and then hit the Install button. And that will install all the default dashboard nodes in teal that I told you about in a couple of slides ago. That will install all those nodes. All right, so let's take a look at the NodeRed website. This is packed full of information. There's a ton of information here. Most of the time that you're going to get into this website, it's going to be for the documentation and the forums. The forums are great. The documentation's even better. So resources. Again, the NodeRed website is great. They've got a YouTube channel. Nick O'Leary kind of gets on there late at night and talks about, he actually programs the back end of NodeRed, and you can watch him live, do smashing bugs and programming new features. It's kind of cool. There's also some really good YouTube channels out there. Opto Video is one. Steve Cope is another one. This guy, I butcher his name, so I won't even say his name. He's got a good YouTube channel. He's got a lot of Internet of Things that he does NodeRed with, but gives you ideas on how you can do different things in NodeRed for your shack. There's a subreddit on Reddit, which is fairly active, not the best, but the holy grail here is the Groups IO, NodeRed for ham radio. We got a whole Groups IO channel, reflector, mailing list, whatever you want to call it, dedicated towards ham radio and NodeRed. This is where we all hang out. There's discussions going on every single day of on this Groups IO, and we ask questions. We share files. We show JSON. We do tips and tricks. Everything that you want to know about ham radio and NodeRed, go to the Groups IO. It's in there. And this is what it looks like. So once you join, you get access to these files. These files are basically all of the shared JSON files that people have put together. And there's hundreds of them for different radios, amplifiers, tuners. Basically, if you got a name brand thing in your shack, I'm sure that somebody has probably got a flow for it. It might not be out here, but if you ask in the Groups IO, hey, I've got a I don't know, a Palstar tuner that I didn't see in the Groups IO files. Can somebody send it to me? Somebody will probably pipe up and send it to you. As of a couple of months ago, these were all the pre-programmed flows that were out there. I just kind of took a snapshot. So all of these devices are out there, with more devices out there too. But if you recognize some of the devices, the flows are out there. And those are in the file section in the Groups IO. Talked about securing NodeRed. I will say that NodeRed is insecure, right? There, you can secure it. It's a pain in the butt, but you can secure it. It is through just regular username and password. But I would suggest highly do not put this out on the internet, because somebody will hack it. And it has been hacked before. I know a huge contester that put their NodeRed system out on the internet because they didn't like security and they wanted all of their operators to get to it. And it was on the internet for about 30 days. And they called me up and said, hey, can you help us get our flows back? Because somebody hacked into it. So don't be that guy. So what's next? So the first thing you should do is join the Groups IO if you want to learn more about NodeRed and all the things that go along with it. Install NodeRed and get up and running. Install additional nodes in the palette. Configure and deploy your first flow. Start small, right? You got to crawl, then you got to walk, then you got to run. Don't install 50 flows and expect everything to work right out of the box, because it's going to take some time to get you up to speed. Learn how to use the debug node. It's your best friend. I don't know how many times the debug node has got me out of trouble. Program a flow on your radio. Like, start with just one thing and get that up to speed, and then add an amp or add another flow and get that up to speed. And then also share your flows on Groups IO. We're trying to get everyone to put their flows out on the groups to help promote and get people thinking. So yeah. And then also I have a YouTube channel that has a ton of NodeRed stuff in my playlists. I've got a whole playlist dedicated to NodeRed. So if you want to check that out, I also do a bunch of contesting, POTA. I run a new CW operators roundtable every 2 weeks on Monday night. I'm a new CW operator, so we talk about the trials and tribulations of being a CW operator. I also run a monthly ham radio trivia through Kahoot, and we play live on Kahoot through YouTube. It's pretty cool. It's all ham radio trivia. Usually it corresponds with Ham Radio 2.0, Jason's happy hour. I usually go first, and then the happy hour second. So we just hang out and talk about ham radio and we stream it, and a bunch of how-to videos. So that's my YouTube channel. Also, I know that you are recording this, but this presentation is out on my website. I'm sorry, out on my YouTube channel. So if you don't see something here that you got a question on, I might have answered it on my YouTube channel. But yeah, that is it. That is the presentation.
Oh, you did. All right. Well, yeah, thanks so much for that, Kyle. Anyone have questions on things? So I guess that's a typical question. What would you recommend as like kind of a starter project, like a get going kind of thing?
Yeah. Let's see. You know, there is, if you have a Raspberry Pi, there is a Raspberry Pi hat that's got like 4 relays on it that sits on top of the Raspberry Pi. That's a good starter project. To just, install NodeRed. There's a flow out there that you can load that connects to those relays and just turns them on and off, normally open, normally closed, and you can play around with that. That's probably a good one. Your basic hello world is another good way to get up to speed. I will tell you, because I don't have a shack here at my house, I do everything remote. All of my learning was basically giving myself a goal of, okay, I want to build a flow that takes a number and turns it into a string, and then maybe it takes a string, and let's say the string is 1,000,000, and it's got a decimal point, and maybe it's got a couple of more zeros or decimal points after that. I want to take that string, I want to convert it to a number, and then I want to round it. So I would do like just different quizzes to myself to get up to speed, because remember, I'm not a programmer. I learned everything that I know from programming from Google. And I have a friend who's a programmer in a large corporation, and I'm like, how do you know all this stuff, whenever you program in the programming language that you program in? And he goes, I don't know anything. Google knows everything. So it's like, oh, well, you do the same thing I do, because I don't know anything about programming. He's like, I don't know anything about programming either. I just Google it. So that gave me a little confidence on, oh, well, maybe you don't have to be the smartest person in the room to figure this stuff out. So you got to start small. If you start big, you're going to get overwhelmed. And I got overwhelmed a little bit too, but you got to start small and just, everyone starts from zero, right? So don't be afraid to ask for help on the Groups IO. That's what I did. I joined the Groups IO and I loaded a flow, and I forgot what flow it was, but I basically just started asking a bunch of questions, and somebody piped in, different people piped in, and I was like, oh, I understand. Okay. I understand what's going on. And then I went from there.
Okay. Cool. Anyone else? Another really quick. I was curious, have you made any notes yourself, or I know there's a whole process of going through that.
Yeah, I just started looking at that like a couple of weeks ago. I have not made nodes myself. And you're talking about packaging nodes and then putting them out on the internet for other people to download. I have not done that. And I just started looking at, I wanted to basically take my contest dashboard. So in N1MM, it sends through UDP packets like the contact that you just made, and your station information, and your radio information. And I have in my contest dashboard, I've got basically a bunch of flows that take all that information and break it out. And I'm like, man, would it be great if I could create some nodes that you just point it to one node, and one node took all that information and took all that XML data and broke it out into parameters. And I would be able to save like 50 nodes on each page by just compiling them all into one node. So I have not done that yet, but I'm looking into it. And there's instructions on how to do that on the web.
I guess a follow-up to that is like, are some of the nodes that are out there just like hierarchical nodes, or are they all kind of made with like Node.js or something like that?
Yeah, I think they're all made basically with Node.js. I mean, there's things out there that I didn't know existed. Like I searched for Morse code, and some person made a Morse code node, like right whenever I think that I'm going to have to like go deep dive and figure out, write a bunch of JS code and basically roll my own solution, I go out to the manage palette, and or I look on the internet and say, I want to actually, what's great is Chat GPT. You wouldn't believe how cool Chat GPT can be whenever you're doing NodeRed. You just basically put in what you want it to do, and it will spit out a bunch of JS code, and you can import that into NodeRed, and it solves your problem.
That is true. Usually need some patchwork, but that's not too terrible.
Yeah, as long as I've noticed, I mean, it's not like really complex, but I've noticed that, you give it a set of parameters and say, I want X, Y, and Z, and here's how you get to it. And it will spit something out. And then you say, all right, that's not exactly what I wanted, but now I know the keywords to put into Chat GPT to make it what I need it to get out of it,
Yeah. One more, I think. So I guess I'm confused about like NodeRed for stuff like Flex, like 6000 series. Like, I guess I'm not seeing the exact practical use for that case, because I know they have their like smart SDR software and all that. Yeah.
Right. So let me show you. Let me bring this over. So this is my remote station here. Can you see that?
Yep.
So one of the things that you don't get on Smart SDR is the input voltage, or the PA voltage, or the PA temp, or the different, I mean, you get this, but all the different information about the Flex node. I mean, you can go searching for it, but this screen right here is nice for when I'm contesting, and I can take a look at what my Flex is doing and how hot it's running. Granted, I've got a 6700, and this is I imported a flow for the 6600. So my 6700 has got multiple fans, so it doesn't know what fan to pick. But the 6700 only has one fan. So you can take a look at the fan speed. And I don't know where you can find that in Smart SDR, but one of my buddies has noticed that his fan was going out and his PA temp was going up. It's because the fan was not rotating at 2700 revolutions per minute, and he could tell that on the NodeRed. You're able to get so much information, raw information, out of NodeRed from your Flex, and I will show you. So let's go into the workspace here. It's going to be a little slow because I'm doing this remote. And if I go into the Flex Radio and I take a look at this debug, let me turn on this debug here. All of that information that you're seeing here, let me turn it off real quick. All of that raw information that you're seeing, now you can do something with. You can graph it, you can display it on the dashboard, you can do a ton of stuff with it. I don't know where you would get that information from Smart SDR, you know?
Okay, yeah, I see that. That's pretty cool, actually.
Yeah. So, you know, Stephen, you know, created these nodes and it queries the Flex radio like, you know, once every half a second, and it pipes, and there's a whole bunch of other information out here, and it's got these flex meters. So here, so this looks like the fan speed, the mic peak, the gain. Let's see, what is that? Here's the PA temp. So you can basically query, and there's hundreds of other parameters that you can get through the API on the Flex radio that you can't see in Smart SDR, you know?
Yeah, it'd be interesting to see what else you can kind of pick out of there. What other
Exactly.
data it provides, yeah.
Right, exactly. You know, instead of the nice thing is, I mean, you're not rewriting an SDR, right? The Smart SDR does SDR stuff really great, right? And it does the things that you want the Flex radio to do, like, you know, change the band and display different parameters. But there's so many other parameters that Flex is not giving you that now you can get out of your radio and do something with in NodeRed.
One other thing I was curious about, I noticed that you had a serially controlled bandpass filter at the beginning there.
Yeah, it's just
exactly,
a bunch of relays.
Oh yeah, is that for HF though? Because that thing looked pretty small for HF.
Yep. Yep. Yeah, it's just the contest bands, and actually they make them even smaller. I think Array Solutions makes some bandpass filters that are like, and they're really, I mean, they're contest grade bandpass. Let's see, bandpass 6-band. Here we go. I love that they're let's see.
Does that do antenna switching as well, or?
Yep. No, it's just bandpass filters.
Oh, okay.
Yeah. Let's see. Yeah. So here's 160, 80, 40, 20, 15, and 10, which are the contest bands. And yeah, it's all compact into this little box. The box is, of course, there's no like, oh, here we go. There you go. There's some, I think these are, these W4, yeah, W3 NQN contest filters. Those are really good contest filters. So you can see there's all the filters for all the contest bands put into one small box.
That's impressive.
Yeah, that's really cool. We have something similar, except each filter is bigger than that box.
Yeah,
it takes up like 5 or 6 view of our rack, or maybe more.
Yeah,
all the filters.
Yeah. Yep. So, I mean, are they now keep in mind, these go before your amplifiers, right? Maybe the filters that you guys have are maybe rated for 1500 watts and after amplifiers, maybe?
Yeah, ours are rated for, they're rated for 2000 watts.
Yeah.
So.
Yeah. Those are going to be huge. Right.
Yeah, they're very, very large. They have huge air core inductors inside.
Right.
But we also
we don't have our amp anymore. We originally designed the system for the amp, and then we discovered the amp doesn't talk with the Flex radio. The one we had previous.
Your BL1000.
Yeah, YouTube BL1000.
Yeah.
So we just run 100 watts now.
Which works. Works
You
fine.
know, you can work the world on 100 watts. I'll tell you that. I mean, so let me bring up, let's see, we're going to leave that. Yeah.
So you're saying this is running remote right now on the Pi at your remote station or whatnot?
Yep. This is all remote. Yep. So this is the latest iteration of basically the command and control. So you can see that I've got some network status here where I take pings and you know, red is off, green is good. Here I'm taking a look at I've got a flow that tells me when the internet was down. So here it says that on 5/24/23 the internet was down at 1939 and lasted for 26 seconds. And then so I logged that. It's got some E layer, and then I also just discovered this a couple of weeks ago. There's a speed test node, and I take all the speed tests and I run this every 2 hours, and I basically graph the upload and the download. We've got gig fiber to the contest station. You can see the last one was 920, and download and the upload was 892, and I just graph that over time, and it just tells me, you know, the bandwidth. You saw some of this Pi stuff over here, and then here are my switches to turn my flex on and off remotely. And then here is our towers, our 3 towers. So here, what I can do is I'm going to click on tower 1, and let's say I want to point to Europe. So I click here, see how it now it's rotating, and this is all happening 2 hours away from me. And it's going to get to somewhere in the vicinity. Granted, the XR5 has got a beam of like 80 degrees, so it really doesn't matter. It's kind of like just pointing and clicking and just letting it go because it's got such a big bandwidth, and then it stops. So let's say I want to point to Africa again. So then it comes back down, and now it's rotating around.
So out of curiosity, do you have cameras to ensure, you know, nothing bad happens to the towers and stuff like that? That's what's been kind of holding us back. Just a tiny. Well, I guess we do, yeah.
No, we don't. We don't. I mean, we have tested this for the last couple of years, and we haven't had any problems with it. I mean, what's gonna has the station gone wonky? I mean, there's limit switches, right, that, you know, are supposed to keep the towers, you know, in check and whatnot. Has this thing gone wonky? Yeah, it went wonky once, and we rebooted the Pi, and everything came back up. Have we had a time where like just everything went to crap and we didn't know what was going on? Nope, hasn't happened. And here I can switch towers. So we are having a little trouble with this 6-pack. We think that there's a thermo fuse that is going bad, and we need to take the thermo fuse out. But these tower switches here, so, you know, on tower 1, we've got the XR5 beam, which is a 5-band beam that we've got. This is the 80-meter vertical. This is the 30-meter beam. And then we usually don't have an antenna on the 4th position. But if I want to change to the 30-meter beam, I just click it, and it's supposed to change. Come on. Sometimes it takes a minute because I'm streaming and doing a bunch of other stuff. Come on. So now you're seeing now I'm locked up. Let's refresh this. Come on. Of course, just whenever you want. So now that's switched. 6-meter beam, 40-meter beam. I'm not sure why that's not switching. Let's try the 8-meter vertical. Oh, it's So you can see that there's some issues, probably because I'm streaming and the way that we have this set up, I've got this running through PuTTY, and I'm doing port forwarding, SSH tunneling, and that's how we're I'm doing this. So this thing doesn't like whenever I'm streaming and controlling it at the same time, it gets a little confused. But you can see here it's changed the 80 meter beam. See if it's going to change here. No, might have to take a look. So let's troubleshoot that. Let's see what's going on. So now we're going to go to localhost, and we're going to see what's going on real fast. So if I go to that.
Have you guys also considered using like VPNs instead of port
Yeah.
forwarding?
Yeah, we have. We have a VPN, but it's just the problem is by the time I get the VPN, I set it, or I log into it, I get everything, it connects, I can be up and running quicker in PuTTY than I can in the VPN. Plus, I don't need the VPN. Smart SDR does everything that I need, and I don't have to create the VPN. So that is the Tower 1 switch, and oh, it looks like it's down. So that device might be down because it's not connecting. See how it disconnected? It's got an error, and then it's tried to connect. So something must be wrong with that. So I need to take a look at that. That's odd on why it's disconnecting. But you can see that this is what it's supposed to look like, where it's connecting and it's basically shooting over its antenna 1. So I don't know why that is acting wonky and why it's disconnected. But yeah, it might be because we use SEER to net, and there might be something wrong with the SEER to net. We might have to restart that service. But yeah, so you can see it's just an ongoing saga, and things break, and you figure out what's going on and fix it and keep going. A remote station, your NodeRed journey and your NodeRed programming is never done. Like you're always coming up with ways that you can improve it. Another thing that we did was in the E layer, we have a contest Discord. And here is where I get statuses of, now I'm pushing statuses from NodeRed into Discord. So here you can see I created a bot, and the Flex got rebooted Wednesday, May 31st at 12:42 Greenwich Mean Time, and it came back up at 12:47. Looks like somebody rebooted it. So I can come over here, and I can actually, the bot is listening, so I can do a question mark, and it will relay the bot status, and I can say, all right, give me the status of AmpRack. So we're going to see the status of the AmpRack. And then I can do an all here, and basically it will just tell me all the statuses of all the devices at the contest station. So it's those little things like that that you come up with, and you're like, oh, I bet you I could probably do this and this if I, put my head together. But I don't know why that's disconnected. We'll have to, I'll have to get into SEER to net and figure out why. It might be just a SEER to net issue.
We should have a NodeRed thing that alerts both when the tower's up and when there's a wind. That would be good.
On Discord.
Yeah, that's good.
All right. Any other questions, comments, concerns? All right, well, I guess another quick hand for you. Yeah, that was a great presentation.
Thanks. Yeah, and if you guys have any questions or whatnot, I'm good on QRZ. Just drop me a line.
All right, sounds good.
All right, is that it?
I believe so.
Okay.